Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today we are going to start chapter number 2, solution. As you know that when two substances mix with each other, they forms a mixture. Mixture basically are of two types, homogeneous and heterogeneous. When we talk about term solution, it is a homogeneous mixture of two or more substances or two or more components which do not react with each other. Now, depending upon the number of components present in the solution are classified as binary solution, ternary solution, quaternary solution. When we say binary solution, it means that it is a homogeneous mixture of two components. Ternary solution, it means that it is a homogeneous mixture of three components. Quaternary solution, it means that it is a homogeneous mixture of four components. Now, depending upon the number of components, we have classified them binary, ternary, quaternary. Remember one thing, in this chapter, we have to deal with binary solutions only. So binary solution is a homogeneous mixture of two components. Out of that, one component is known as solute and another component is known as solvent. So when the component which was present in lesser amount or less quantity in the solution is known as solute, while the component which was present in larger amount is known as solvent. Since we know that the state of the solution depends upon the state of the solvent, means whatever the state of the solvent, that will be the state of the solution. So we can define the component whose state resembles with the state of solution is known as solvent. Now, depending upon the nature of solvent, that solvent can be solid, solvent can be liquid, or solvent can be gases. Solutions are of three types: gaseous solution, liquid solution, solid solution. When I say gaseous solution, it means that in this solute is gas as well as solvent is gas. If I say liquid solution, in this solvent is liquid, and solid solution, solvent is solid. Now, depending upon the nature of the solute, they can be gas plus gas, liquid plus gas, solid plus gas. Similarly, when we talk about liquid solutions, here also gas plus liquid, liquid plus liquid, and solid plus liquid. In case of solid solutions, again gas plus solid, liquid plus solid, and next one is, that is solid plus solid. One by one we will see the examples of this gaseous solution. For example, when we say gas plus gas, it means that it is a homogeneous mixture of two or more gases. The best example is air. When we say liquid plus gas, so you can take an example of water vapors which are present in air. Solid plus gas, so you can take an example of a smoke in which the carbon particles, solid carbon particles are dispersed in gas. Gas plus liquid, in case of liquid solution, gas plus liquid where the solvent is liquid. We can take an example of carbonated drinks where you know that CO2 was dissolved in water at a very high pressure. Liquid plus liquid, for example, we are mixing alcohol in water and it forms a homogeneous mixture. Solid plus liquid, again we can take an example of a salt solution or glucose solution where they are dissolved in water. Next one is, that is gas plus solid. Here we can take an example of when hydrogen gas was adsorbed over the surface of platinum or palladium. Liquid plus solid. So here we can take the example of gel. Solid plus solid. Here we can take an example of alloys, which are the homogeneous mixture of two or more metals. Now another term which we are dealing with is concentration of solution. It is the amount of solute which was present in the solution. It is the amount of solute which was present in the solution is known as concentration of the solution. Concentration of the solution are of two types. We can express the concentration qualitatively and quantitatively. When we say that qualitatively, it means that as you have studied in lower classes, dilute solution and concentrated solution. Or we can say that dilute acid and concentrated acid. In this, if we say that qualitatively dilute solution, it means that the concentration of solute relative to solvent is very, very less. But when we say concentrated solution, then the concentration of solute relative to solvent is very, very high. Then that solution is known as concentrated solution. But in this chapter we have to deal with quantitative concentration. So quantitatively, the concentration of the solution was expressed by mass by mass, mass percentage, by volume percentage, by mass by volume percentage, part per million, mole fraction, then molarity, and the last molality. So one by one, we'll take the various ways of expressing the concentration of the solution quantitatively. First one, when we say mass percentage. Mass percentage is defined as the mass, or we can say that weight of one component divided by total weight of solution into 100. When I say that weight of one component divided by total weight of the solution into 100, for example, 10% NaCl solution, if I say that 10% NaCl solution, NaCl aqueous solution, m by m, mass by mass, it means that 10 grams of NaCl was dissolved in 100 grams of solution. When I say 100 grams of solution, it means that 10 gram of NaCl plus 90 gram of water. Another way of expressing the concentration of the solution is volume percentage. Here, volume percentage, V by V percentage, that is, it is defined as volume of one component divided by total volume of solution into 100. Again we can say that if suppose I say that 10% V by V ethyl alcohol solution, it means that 10 ml of alcohol was 10 ml of alcohol divided by 100 ml of solution, means 10 ml of alcohol plus 90 ml of water into 100. Another way of expressing the concentration is mass by volume percentage. Mass by volume percent, this is the most common way of expressing the concentration of various contents which are present in the medicine or the syrups, and especially it was used in the pharmaceutical companies. For example, if I say that 10%, it is defined as mass by volume percent, it is defined as the weight of one component divided by total volume of solution into 100. For example, if I say that 10% KCl solution M by V solution, it means that 10 grams of KCl was dissolved in 100 ml of water. In this way, we can say that the 10% mass by volume concentration of KCl. Another way of expressing the concentration of solute in the solution is part per million. Basically, when the concentration of solute is very less in comparison to that of solvent, then the concentration was expressed in part per million, commonly known as ppm. For example, if I want to express the concentration of calcium bicarbonate in water, or during the expressing the hardness of water, we are expressing the concentration of calcium hydrogen carbonate in ppm. It is defined as the number of parts by either by mass or either by volume of one component divided by total number of parts of components into 10 raised to the power 6. For example, if I say that 5.8 ppm of calcium hydrogen carbonate, it means that number of parts by mass of one component, that is of calcium hydrogen carbonate, is 5.8 grams divided by total number of parts, means in 1 million part, that is 10 raised to the power 6 into 10 raised to the power 6, and that is why we can express the concentration of that calcium hydrogen carbonate in water as 5.8 ppm, means part per million. Another way of expressing the concentration of the solution is mole fraction. It was represented by, this mole fraction was represented by X, and it is equal to number of, it is the ratio of number of moles of one component divided by total number of moles of various component present in solution. For example, we are dealing with binary solution in this chapter. So here, if I say that two components are there, one component is A and another component is B. So mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B, which forms a homogeneous mixture which are forming the solution. Similarly, if I want to calculate the mole fraction of B, so mole fraction of B is equal to NB upon NA plus NB. Now remember one thing, XA plus XB is equal to 1. And if suppose three components are present, then if another component C was present, for example, then the mole fraction of XC is equal to NA divided by NA plus NB plus NC, like that, and whatever the number of components which are present in the solution, according to that we can calculate their mole fraction. Another way of expressing the concentration is molarity. It is represented by capital M, and it is defined as number of moles of solute present in per liter of solution, volume of solution in liter. As we know that number of moles is equal to mass in gram upon molar mass, so we can write the mathematically, we can also express it as, that is, if suppose I am taking B as a solute, then mass of solute divided by molar mass of solute into volume of solution in liquid. As we know that number of moles is equal to mass in gram upon molar mass. Another way of expressing the concentration of the solution is molality. When we talk about term molality, it means that it is represented by small m and it is defined as number of moles of solute dissolved in per kg of solvent. Per kg of solvent. Again, we know that number of moles is equal to mass in gram upon molar mass. So mathematically we can also write it molality is equal to, that is weight of solute divided by molar mass into weight of solvent in kg. So these are the certain ways to express the concentration of the solution. Now, the concentration of the solution was also get affected by temperature. For example, if we say that mass by mass percent, or if I talk about molality, these are the two ways of expressing the concentration which do not generally get affected by, or which do not get affected by temperature. But if I express the concentration in terms of molality, V by V or M by V, so definitely we know that volume get affected by temperature. It increase by increasing the temperature and it decrease by decreasing the temperature. It means that the concentration, if we are expressing the concentration of solution in terms of molarity or by volume or mass by volume percentage, then definitely the concentration was get affected by temperature. One more way of expressing the concentration which do not get affected by the temperature is mole fraction.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.